Good morning. All right, today we're going to go over dilutions, which is our next step to looking at molarity and concentration of solutions. All right, so we obviously can't do the full-on demo, but we'll walk through this portion of our notes. So how do we make a 1 molar solution of sodium chloride? Okay, so we want to remember that 1 molar solution of sodium chloride is moles per liter of solution. Okay, so we know we have 1 gram or 1 mole of sodium chloride. So how many grams are in 1 mole? We would look at the molar mass, and it would be 58.44 grams per every mole of sodium chloride. Okay, so how do we mix the sodium chloride in water? And this is where we want to really kind of pay attention to what we're looking for. So if we're looking at a 1 molar solution, sorry, let me get this. Okay, so here are our options. So if we're going to make a solution, so are we going to pour 1 liter of water into a graduated cylinder, then add sodium chloride to it? Our next option would be to pour 500 milliliters of water, then add the sodium chloride, then add the rest of the water till we get up to 1 liter of solution. Or we dump in the NaCl and then we add water to our solution. Okay, so before we reveal the answer, let's just kind of talk through. So if I have 1 liter of water and in a graduated cylinder, then I add sodium chloride. I will then end up with more than 1 liter of solution because, of course, my sodium chloride has mass, takes up space, has volume. So I will end up with a solution, more than a liter of solution. So that's not our option. The bottom option, dump in sodium chloride and then add water. Not the best option because we're not dissolving right away. So we're going to end up, getting stuff stuck to the bottom. So our best option is to pour half of the water or about half the water that we need, then add the sodium chloride, and then we continue to add water till we get up to the 1 liter mark for our solution. So that's basically how I go about using the molarity problems that we did Friday and that we just went over in the previous video. And then this one, now that I know the amount, what do I do to actually make this solution? So this is what we would do. Add a water to our graduated cylinder, pour in the amount that's needed to get to the molarity that I'm looking for, and then add water to my given volume that I'm looking for. Okay, so why would I need to go ahead and dilute a solution? And a lot of times we buy stock solutions and they're in concentrated form. Why do we do this? It's cheaper, it's more versatile, it gives us, it's uniform for one, but then I can create whatever molarity I need for whatever lab we're doing. All right, so however, we to be used to use the stock solutions, we would need to weaken them first. Okay, so that's where dilution comes in. So dilution is just reducing the concentration of a chemical solution. All right, so here is our how-to guide. So the main method of diluting is to add water. Safety tip. So this is something that you want to keep in mind as we go to make solutions. So acids and bases must be diluted by adding to water rather than the other way around. Why do we do this? Water has a pretty high heat capacity, meaning that it can absorb the heat when the acid is added. If we add water to acid, we can have a situation where the acid would kind of splash out and cause a major hazard because the acid can't handle the absorption of heat that's created when the two are mixed. So now that we know we will always add acid to water to make our solution, how much water are we going to add, and how much of the concentrated solution do we need? All right. Okay, so first, to determine how much concentrated solution is needed, we're going to use the following equation. It's M1V1 equals M2V2, and each one of those stands for, so the M1V1 is your initial, your beginning molarity and the initial volume you have, and then M2V2 is your final molarity that you might be looking for and your final volume. So a dilution is a procedure for preparing a less concentrated solution from a more concentrated solution. And so we can kind of see from this diagram, the number of moles of solute before and after is the same. It's that we've added more of our solvent to decrease that concentration. Okay, so at this point we have a couple of sample problems that we are going to look at. So if we're looking at using a stock solution that we kind of talked about at the beginning, we want to answer this question. So the molarity of sodium chloride we made at the beginning was 1.00 molar. So what volume of this sodium chloride stock solution must be used to prepare if I only want 0.75 liters of a 0.300 molar solution of sodium chloride? So my M1 is 1.00 molar. My V1 is what I'm looking for. My M2 is 0.300 molar, and my V2 is 0.750 liters of solution. So I'm going to take these and I'm going to write it in my equation right here. Okay, so 0.300 molar times V1, I'm going to put that in parentheses, equals, oh goodness, hang on, we're going to start again. My M1 is not 0.3. All right, so you can see what I wrote on the screen. So our equation is M1V1 equals M2V2. So the first thing to do is identify what molarity and volume go together and what for M1 and then for M2. All right, so now that I have them identified correctly, what goes with what, I'm going to put it into my equation. So my N1 is 0.100 molar. I'm going to multiply that by my V1. And then my M2 is 0.300 molar. Put my decimal there. And then my volume is 0.750 liters. Okay, so if I look, my M's are canceling, so I'm just going to get those out of the way so that I don't have too many letters here. My volume unit over here. So I'm going to rearrange. I'm going to solve for V1. And I end up with 0.225 liters is the amount that I need for my 1 molar solution. All right, so now we're going to see if we can move on to our next example. All right, so here is example problem number 1. All right, the molarity of a concentrated hydrochloric acid is 12.4 molar. What volume of concentrated solution must be used to prepare 2.00 liters of a 0.250 molar solution of hydrochloric acid? All right, so we are going to identify our variables. Okay, so what volume of concentrated solution must be used? So I'm going to start with M1 is 0.250 molar solution of hydrochloric acid, and then V1 is 2.00 liters. Now, it doesn't really matter which one's M1 and what is M2, as long as you have them paired correctly, the answer will come out to be the same. So I'm going to say M2 is my 12.4 molarity, and then V2 is what I'm going to be looking for in the end. All right, so I'm going to go ahead and take what I have, and we have 0.250 molar. The volume I'm given is 2 liters. Then I have a concentrated solution of 12.4, and I'm looking for V2. Sorry, squeeze that in there. All right, so V2 is going to equal, I'm going to multiply 0.250 times 2, divide that by 12.4, and if I did my math correctly, I'm going to get 0.0403 liters is the amount of 12.4 molar solution I'm going to need. All right, so we're going to clear the screen. We're going to try our next problem here. If I can get my screen to advance. Let's try it one more time. There we go. All right, example number 2. It says, what concentration of potassium dichromate was used to make 250 milliliter sample of 0.1 molar potassium dichromate if we started with 5 milliliters? All right, so in this case, I'm going to go ahead and first identify what goes together. So M1, I'm going to say is my 0.1 molar. Okay, and then my V1 is 5.00 milliliters. Okay, what you're going to notice is I'm not changing my volume unit, because as long as the volume unit is the same, then I don't need to be in liters. I just need to have the same unit on both sides. Okay, so we're looking for molarity, and I'm going to keep my V2 in milliliters. There's just no reason to take the time to convert that to liters. Okay, since I have milliliters for V1 and milliliters for V2, I'm ready to go. So I'm going to go ahead and put this in my equation. 0.10 molar solution times my volume of 5 milliliters, my decimal point there, equals my M2, which is what I'm looking for, and I'm going to multiply it by 250 milliliters. And my M2, if I have done my math correctly, I should end up with 0.0020, to be with the consistent sig figs, molar solution of potassium dichromate is what is needed for that problem. Okay, so we're going to try and see if we can do one more problem here. Again, give me a second to advance. There we go. Okay, so here is our last problem. If you have a stock solution of 14.8 molar ammonia, how many milliliters of this solution should you dilute to make 1,000 milliliters of a 0.25 molar solution of ammonia? Sorry. So again, it's asking for milliliters. The volume unit I have in this problem for my M or V2 is in milliliters, so I don't need to change that. So I'm going to say my M1 is my 14.8 molar. I'm going to look for V1. Okay, again, it doesn't matter which one I'm identifying as M1 and M2 as long as they're paired with the right volume. Okay, so I have 0.250 molar concentration is what I'm looking for of a volume of 1,000 milliliters. All right, so I'm going to plug this into my equation. Say still M1 V1 equals M2 V2. So there's my molarity times my V1. My concentration of 0.250 molar times 1,000. It's asking me to end in milliliters, so I don't want to change this unit. So my V1 is going to end up with, so I'm taking 0.250 times 1,000 divided by 14.8. And again, if I've done that correctly in my calculator, it's 16.9 milliliters of that concentrated solution is what we need. All right, so that should be our last practice problem for this. So now what I have for you to do is a mixed worksheet where you're going to work on molarity, a few molarity calculations first, and then the second half will be dilution problems just like you're seeing today. All right, so head on over to Canvas and you'll see that worksheet. You could print it out, or if you just need a piece of notebook paper, you can just write the work there, and then we will catch up hopefully when I see you tomorrow.